Hello and welcome to Shortcut Up CNC. Today we're going to talk about a gadget I've created. It's the miter fold box gadget. And we're just going to run through it real quick here, show you how it operates. And then we'll have another video that I'll produce that'll show more detail as to how the miters and all were created and the relationships between the offsets and the tooling that's involved in creating the miters. So let's go into looking at the setup of the miter fold box gadget. We're going to set up a project here. It's a single-sided 25 by 25 is standard for this particular gadget. That's in inches. And we're going to start off with a 1/2 inch material. This gadget can work with material thicknesses from 1/4 inch all the way up to 1 inch. And zero position, I like to use the material surface. You can use the machine bed if you prefer that. The gadget prefers the XY datum being in the center, and then we say OK to that, and it sets our project. Now we'll go change this to layers so you can see the layers coming in along with the gadget when the gadget creates the miter full box layout. Here is our interface. You have the box width, which is on the x-axis, and this is all set up in my respective. And then the y is the length for the vertical. And then you have your side heights. I'll show you that in a few minutes, how that's created. And then you got your material thickness. That should be the same as your job setup. And this is the offset vector distance and the gaps between each one of the created vectors. There's a set of 5, sometimes 6, it depends on the thickness of the material, of your offsets. We're going to change this one to 0.25 for the 1/2 inch material thickness. And it repeats everything that you put in and shows the feedback. You got a 12-inch by 12-inch with 4-inch sides. The 4-inch sides is measured from this center vector of these clusters, each one of these clusters of vectors. The center vector is your locating vector for the width, length, and the side. The side is combined, measuring from the center here to this outside perimeter boundary cut. That's your 4-inch sides. These 4 corners are scrap. Your sides are 1, 2, 3, 4 sides here. Then you have your material thickness being repeated, and the offset width of each one of these vectors is 0.25, and there's a maximum of 2 offsets. And what that's telling you there, in fact, I need to remove an S. Anyway, what this is telling you here is that you have 2 offsets from the center vector. The first set of offsets on either side of the center line vector is the offset 1, okay, in your layers. And then offset 2 is the one that's the furthest out from the center vector. And then you have your profile cutout vector. I will show you these right now. Okay, you got your center vector, that's your locating vector that gives the bottom of the box 12 by 12. The sides is measured from here to the outside boundary cut, which I just put up. Now we'll take the boundary cut out and we'll show you the first offset. And I'll click it off and on a couple times and you can see it. Now we'll go to the second offset of those vectors. This is what's used to put the V bit on to carve the miter. And I'll show you that after I click all those back on. And with the gadget does not have the tool pathing. There's too many variables involved, and you need to fine tune the tool pathing in order to get a nice smooth miter for each one of these cluster groups of vectors. So the best thing to do is to create your tool paths one at a time, and then you save the tool paths as a template for that particular material thickness. And another note here, that toolpath template for that particular thickness can be used for any size box that you create for that thickness. So in other words, you don't have to create another set of tool paths for a different size box. If the material thickness is a ½ inch, you continue to use that toolpath template. So let's bring in my toolpath template and you'll see what I'm talking about. I identified it as a ½ inch with a 2.25 offset. We'll go ahead and load that. And then the next thing you want to do after you've loaded it, you go calculate it. Now we'll play the preview. And of course, I'm noticing that it's only using one offset. It didn't need the second offset. When I created it, that's what I found out, that I didn't need my second offset. So I only created the two tool paths. Well, actually, it's three. One is for the center lines, and then the offset of that from the center line, and then the profile cutout. Let's play that and you'll see what it does. That's kind of fast. I got too many passes on that, but that's okay. That can be fixed. So there you see the miter fold box. These four corners are scrap. You got your four sides and you got your bottom. And the miters are nice and clean. There you have it, folks. A miter. In fact, let's do it again, only I'm going to change this box size so that you can see it's an uneven box. So let's go close everything here, recreate from the start, project all the same, and then we go get the gadget, and I'm going to make it a 6-inch width on the x-axis, make the narrow or the long end on the y-axis. And the miter fold you see here, this is after the fold, it's 4 inches. 6 by 12, let's change it to 3 inches, and then you can see that it does actually create the vectors accordingly. And there's our repeat showing everything, and it's showing a two offsets, which we may not have to use those two offsets, but we're ½ inch thickness. So we'll see when we bring in the toolpath template And there you see all the layers that were created, your default layer along with the others. And there it's created the box in an unequal size. And it's got 3-inch sides instead of a 4-inch side. 6 by 12 by 3. And we can verify that by going to the design and clicking on here. And we measure from the center outward 3 inches, which shows right here 3 inches. And then we go the other direction, it says 3 inches also. And then we can measure, we close that and do it again. And we'll measure from, well, actually, I could have gone from here to here. And you notice it says 6 inches wide. And we go the other direction to the center. It's 12 inches long. So the box is created properly. Now what we'll do is close this. We'll bring in the toolpath template, which is a 1/2-inch tool template. And then we'll calculate. And now we'll preview that and see what we have. It looks like the miters are nice and smooth, and you only needed the one offset. So bravo, it worked fine. The Gadget creates a few more offsets, and the reason for that is because the tooling involved does play a factor in the layout of the miter. Right here, I'm using a 1/2-inch cutting height. If you use a smaller cutting height, you're going to have to maybe use one of those, more of those offsets. In this particular case, I only needed to use the one after the center line was cut. It just goes up, cuts the center line, moves out a bit, and then the depth doesn't go down as nearly as far. In fact, let me close this and we can take a look at the depth. See, the depth there is about half of the thickness. And one other thing I want to mention that I did with this also is the miter fold. Hello. Okay, won't get rid of my material till I get that back. Now I can get rid of the outside. Okay, if you notice here at the bottom of the miter, that is 15 thousandths. That's for the fold so that you don't see a cut on the corners, especially when we use MDF board. When you use an MDF material board, that thin layer that holds the board all together will fold around like a little contour rather than having a cut through here. Now, if you do cut through, be sure to use tabs on your outside cutout because the parts will be all cut apart from each other. And if you're using the four corners for clamping, your sides for the box will not be held. So, and if you prefer to try to keep things all together, you can use tape on the back side of your material board. And it may cut through the tape sometimes, but it's a safety measure that you can add the tape and hope that it doesn't move. But the best thing to do is to use tabs on the cutout around. I don't have tabs set on this right now, but that is one of the best things to do. So there you've seen how the gadget functions and how it creates the box in different sizes. And in the next video, I will show how to create the uh, miters, because when you put in the various different measurements, the width versus the depth, it may have staggered uh, contour on the inside of here. In fact, I'll tell you what I'll do real quick. Like, what I'll do is I'll change this to 200, and we'll calculate that, and then we'll reset everything, and we'll preview all toolpaths, and you'll see what I'm talking about. You will have to fine tune the miter based on all the different variables, your uh, tooling involved, whether the cutting height is half inch or 3/8 of an inch. See the little line on the inside? If I go tight, you can see that it's staggered. In other words, what's happened is you don't have enough depth here. It staggers. You can see that right here on the edge, the end grain. So you'll have to fine tune the miter. Once you have a tooling involved, like whether you decide to use the 3/8 or a half inch, all you got to do is keep changing the depths. And you also have to watch that the offsets. The offsets really don't play a whole lot in it, but it can, because in this particular instance, it showed I only needed to use the one offset instead of two. But the gadget automatically creates two. You can go ahead and delete this if you don't need it. I mean, the gadget functions properly. It's just that you got to go in and make a lot of changes now and then to get it to show a perfect or near perfect miter for the miter fold box. So thank you for watching Shark Cut Up CNC.